Namaskar, welcome to PK's classes. Today we are going to study about the nicotinic acetylcholine receptor. So in short we write NACH. Nicotinic acetylcholine receptor, as we know, the cholinergic receptors can be muscarinic and nicotinic. So the cholinergic receptors are of two types, muscarinic and nicotinic. So we are going to study about this nicotinic acetylcholine receptor today. You can refer to our earlier classes on M1 receptor, M2 receptor and M3 receptor. So this nicotinic acetylcholine receptor is a ligand gated ion channel or ion channel linked receptor. That means this receptor is linked to one ion channel. So you can see here the ion channel, the pore is there, and it is a pentameric structure. So 5 subunits are there. Here you can see 5 subunits: alpha 1, beta 1, delta, alpha 1 and gamma. 5 subunits are there, and it is a pentameric structure. So you can see these are the subunits, 5 subunits, and those subunits can be of 5 types: alpha, beta, gamma, delta and epsilon. So far total 17 types of subunits of this nicotinic acetylcholine receptor have been identified. Out of them, alpha is of 10 types, beta is of 4 types and the rest are of only 1 type. So total 17 types have been identified, and these 5 different units together they form the ion channel linked receptor, and all the 5 may not be a part of that. Mostly alpha and beta, these two are part of the receptor, and in some cases only alpha, and in some cases all of them they are involved. May not be all of them, 4 of them are involved, maximum 4 of them are involved. So the different combination can be, suppose alpha 10 types means alpha 1, alpha 2, alpha 3 up to alpha 10, beta 1, beta 2, beta 3, beta 4, and gamma, delta, epsilon only 1 type. Suppose alpha 7 and all the 5 subunits are alpha 7, this is 1 type of receptor. Similarly 2 can be from alpha and the other 3 can be from the rest. So there are different combinations, and you can see here in this figure there are 2 alpha subunits, 1 beta, 1 delta and 1 gamma subunit, and all these 5 together form a pore, and through that pore the cations like sodium, potassium, all of them move. And why they move, you can see here this lining, the lining of each of the subunit, they are negatively charged because of presence of the negatively charged amino acids, and because this lining is negatively charged, it is permeable to cations. So sodium and in some cases calcium and can move inside from outside to inside, and potassium can move from intracellular to extracellular to outside. But the net force will be, movement will be that due to sodium. In case of sodium and potassium, the net movement will be the sodium influx and hence the net effect will be depolarization. And you can see in this figure the 5 subunits are alpha 1, beta 1, delta and gamma. 2 alpha 1 are there, and there are 2 binding sites. Those binding sites are to alpha 1, and its neighbor here it is gamma. It can also be epsilon. So 2 acetylcholine molecules bind to these 2 sites. So this is another structure. 5 units are there, and these 5 units can be different. And this is the pore. Through the pore, which is of 0.7 nanometer diameter, the cations move, and the cations move because the lining of this pore is lined by negatively charged amino acids. Another thing is, in each subunit there is the alpha helix. So alpha helices of all the 5 subunits, suppose this is the helix, so all the 5 subunits, they form the gate, and because of that there will be closing of the ion channel. So these alpha helix, they because of presence of this alpha helix, it is closed, and when this alpha helix is straightened, the channel opens. So when 2 acetylcholine molecules bind to these binding sites, which are located between alpha and its neighboring subunit, this alpha helix is straightened, and when they are straightened, the pore opens and the ion channel opens, and there can be movement of sodium to inside, potassium to outside, but the net movement will be by the movement of sodium, and the net action will be, that is, depolarization, because the influx of sodium is greater than the outflux of potassium. So if you see, each subunit spans through the cell membrane 4 times. 1, 2, 3 and 4. 4 times it spans. So since we have 5 subunits, so total we can have 20 membrane spanning helices. And out if we see the subunits, then we can have 4 subfamilies. So subfamilies 1, 2, 3 and 4, and 1, 2, 3 are neuronal, present in the neuromuscular junction, and 4 is the muscle type, present in the skeletal muscle, and neuronal, they are present in the neuromuscular junction. The skeletal muscle, they are present in the neuromuscular junction, whereas this is neuronal, means this is present in the ganglion, and in CNS it is present in the brain. Okay, so neuronal 1, that consists of the alpha 9 and alpha 10 subunit. Then type 2 subfamily, alpha 7 and alpha 8. As we have discussed, alpha can be of 10 types. So these subtypes so far have been identified. Then subtype 3 the subfamily 3 again has three subtypes. The first subtype consists of alpha 2, alpha 3, alpha 4, alpha 6. Second subtype beta 2, beta 4. Third subtype beta 3 and alpha 5. So all these are present in the neuron. And in the muscles, these subtypes are found: alpha 1, beta 1, delta, gamma and epsilon. So delta, gamma and epsilon are mainly found in muscle, and among the different subtypes of alpha and beta, alpha 1 and beta 1 are found in the muscle and the rest are found in the neuron. So nicotinic acetylcholine receptor can be present in muscle, so nicotinic muscular receptor, and in the neuron, that is nicotinic neuronal receptor, and that can be present in ganglion in the peripheral nervous system, or in the central nervous system it can be present in the brain. So as we just discussed that there can be different combinations of all these 5 subunits. So in muscle, 2 alpha 1 subunits are there, 1 beta 1 subunit is there, 1 delta subunit is there, and the 5th subunit can be either epsilon or can be gamma. So these 2 types of combinations are there in neuromuscular junctions, and these receptors are postsynaptic and they are permeable to sodium and potassium. But the net action is that due to sodium, because sodium influx is more than the potassium outflux. So out of these 2 combinations, alpha 1, 2, beta 1 and delta and epsilon, this is mostly present in the neuromuscular junctions. In autonomic ganglia, the ganglion type, there can be 2 combinations: 2 alpha 3 subunits and 3 beta 2 subunits, or 2 alpha 3 subunits and 3 beta 4 subunits. Again, out of these 2 combinations, this is again the most commonly present combination of nicotinic acetylcholine receptor, where 2 alpha 3 subunits are there and 3 beta 2 subunits there. Then in the CNS type, that means it is located in the brain. This receptor can be either presynaptic and as well as postsynaptic, whereas in muscle and ganglion it is postsynaptic, whereas in brain it can be both pre as well as postsynaptic, and this can be homomeric as well as heteromeric. Homomeric, it consists of alpha 7, only alpha 7 subunit. All the 5 subunits are alpha 7, and if both alpha and beta are present, then it is heteromeric. 2 alpha subunits and 3 beta subunits, total 5 subunits combination, that is heteromeric. And 2 alpha 4 or alpha 3 can be there, and 3 beta 2 or beta 4. So 2 alpha 4, 3 beta 2, one combination, 2 alpha 3, 3 beta 4, that is another combination. But the most common is this combination consisting of 2 alpha 4, 3 beta 2. So we can summarize here. And again, this homomeric one is permeable to calcium in addition to sodium and potassium. The rest, all the other receptors are permeable to sodium and potassium, but this homomeric CNS type nicotinic acetylcholine receptor, which consists of all the 5 subunits as alpha 7, is permeable to calcium in addition to sodium and potassium. So we can have mainly three types of receptors found in mammals. In muscle it is alpha 1, 2, beta 1, epsilon, delta. In ganglion it is alpha 3, 2, beta 2, 3. In brain it is alpha 4, 2, beta 2, 3. Then we can have different agonists and antagonists. So this is a summary of your agonists and antagonists at different receptors in muscle, in ganglion, and in CNS. So the examples are there, you can note down, and just you can remember this one. Varenicline one is one molecule which is partial agonist of this alpha 4 to beta 2 3 CNS type nicotinic acetylcholine receptor, whereas it is a full agonist at this alpha 7 5 type CNS type nicotinic acetylcholine receptor. And in this case, alpha 3 2 beta 4 3, these are the agonists, and these are the antagonists. So all the examples you can note down and remember. The Spirantel, the anthelmintic drug, is agonist of muscle type alpha 1 2 beta 1 delta epsilon type nicotinic acetylcholine receptor. So this is all about the nicotinic acetylcholine receptor. Thank you.